Hello, today's videos are about geometry review and then algebra review. So this was our very first unit of the year about transformations. And this is going to be important in your Algebra 2 course because they're going to talk about transforming functions and creating different types of graphs. So for this first part, we're going to be looking at matching the type of transformation to the diagram. So here, translation. This is a rigid transformation where we use a vector to move an image, the pre-image, up, down, right, or left. So that is this diagram. This is a translation. We can tell because it has the vector and the pre-image has been moved up and to the right. Okay, this one here, well, we start with the pre-image and that's bigger and we're creating a smaller image. Well, there's only one of these that changes size and that's dilation. Dilations change size by a scale factor. We also have to find a reflection, and that is this one in the bottom right corner here. It's being reflected over the y-axis. It's taking the pre-image and we're flipping it or reflecting it over. And then last but not least, we won't do green, let's do purple, a rotation. A rotation, we're taking an object like this right here, and we've got a center of rotation and we rotate a number of degrees. I think here this looks like 90 degrees to me almost. And we're rotating it in a direction. This is going clockwise. So that's just a quick review about translations, reflections, rotations, and dilations. So what you'll also be asked to do on the Desmos activity is actually perform the transformations on the coordinate plane. So for example, this says, translate the pre-image with the transformation. X, comma, Y, arrow. So this is saying start at the pre-image and move it x plus 5, so this is to the right, 5, y minus 2, down 2. So we're going to pick a point, let's say point G, we'll go to the right 5, 1, 2, 3, 4, 5, down 2, 1, 2, and this is going to be G prime. We'll pick another point, point O, we'll go to the right 5, 1, 2, 3, 4, 5, down 2. This is going to be O prime. Last one, to the right 5, 1, 2, 3, 4, 5, down 2, 1, 2, D prime. And then we'll connect the dots. And we'll create our new triangle. And then the last piece is to draw a vector. So that's an arrow going from vertex to corresponding vertex like O to O prime to show the movement. So that you are going to be asked to actually do the transformation on the coordinate plane. Another thing you might be asked is, here is a translation. Complete the vector notation. So how far has they been moved? So we know that we're going from M to M prime. This is the pre-image because it does not have primes. And this is the image because of the primes. That's what tells us. So we are going from x comma y to x, and then it's either going to be plus or minus something, and y plus or minus something. So for here, for x movement, we are going to the right, so that means we are going to add. How many are we going to the right? Well, we're starting here. We're going to 1 over 2, 3, 4, 5, 6, so x plus 6. Now y, we are going down, so we are going to subtract. How many are we going down? 1, 2, 3, so y minus 3. And that would be completing the vector notation. You might also be asked to find a mistake in a student's work. So looking at this translation, we can tell that the triangle in black is the pre-image because it does not have primes. And so if we were to draw a vector between the two, we'd go from A to A prime. So we're going 1 to the right, so that should be x comma y. x plus 1, and then 1, 2, 3, down 3. So this part here is correct because we're going down 3, but this is incorrect because it shouldn't be minus 1, it should be plus 1 because we're moving to the right. So that's a quick review of translations. We also have reflections. So you will be asked to reflect an object over an axis. So for example, over the x-axis, we'll highlight the x-axis. And what we'll do is we'll take each point and move it a certain distance. So point C is 1 up from the x-axis. So we're going to flip it 1 down over the x-axis. And so this becomes C prime. J is 1 up as well. Flip it down, J prime. So we're reflecting over. M is 1, 2 spaces. So we'll go 1, 2 spaces. Up. Flip it over, M prime. K is 1, 2, 3, 4 spaces. Down, so we'll flip it 1, 2, 3, 4 spaces up and land on K prime. Now I'll erase all this other extra. I think we lost our C prime. There we go. Extra marking so that we have more of a clear picture that we can start connecting dots to. Oh, let's use blue. So M prime to C, M prime to K prime, K prime to J prime, and C prime to J prime. So here we have our image that's been reflected over the x-axis. So each point is now on the opposite side of the x-axis. Oh, I don't know why it says dilations. That should say rotations. The other part that you'll be asked to do during the Desmos activity is to rotate a shape on the coordinate plane. So for example, here we're going to rotate the shape 90 degrees. CCW means counterclockwise. About the origin. So remember that the origin is the point 0, 0. Just a refresher about clockwise. Clocks move like this. So clockwise is going in this direction, that's clockwise, and counterclockwise would be going in the opposite direction. So the first thing we're going to do is we're going to plot our center of rotation, which is the origin, 0, 0. The next thing I'm going to do is I'm going to think about, okay, I'm going counterclockwise, so I'm going against the clock. That means I'm going in this direction. Then I have to think about, what does 90 degrees look like? Well, if I'm going to start by moving point Z, I'm going to create a 90 degree angle with this as one of the rays in the purple direction. Ah, that's a 90 degree angle. So what I'm going to do is I'm going to count the spaces 1, 2, 3, 4. 1, 2, 3, 4. This is going to be Z prime. I'm going to do a similar process for L. I'm going to highlight, going from L, move it 90 degrees. That's going to be in this direction. Here, that's a 90 degree angle. That's really nice. Okay. L is 1, 2, 3 spaces away, so it's going to be 1, 2, 3 spaces away. And this is now L prime. For J, it's a little bit more complicated. So I'm just going to erase a little bit so that we have a cleaner slot. Okay, so from J here, how can we measure 90 degrees? Well, this one's a little bit more complicated because it's not on an axis. So what we're actually going to do is we're actually going to find the slope of the line that's connecting the origin to J. So here we have 1, 2, 3, 4, 5. That's -5. 1, 2, -2. So our slope triangle here, so the slope here is -2 over -5. So what we're going to do is we're going to approximate we know that if we move in the purple direction, we're going to be entering into this quadrant at 90 degrees. So what we're going to do is we're actually going to take this slope here is 2/5. To get the perpendicular slope, we're going to take the opposite. So it was positive, now it's negative. Reciprocal. So flip the numerator and denominator. 5/2. So from here, we're going to go to the right 5, 1, 2, 3, 4, 5, and down 2. And we will get J prime. That's not correct. I'm sorry. Sorry, down 5. 5 is in your numerator, so down 5, 1, 2, 3, 4, 5, to the right 2. I apologize. J prime. So when we're looking at the new triangle we've created, it has been rotated 90 degrees. And like looking at this, that is also a 90-degree angle as well. So rotating is a little bit more tricky on the coordinate plane than reflections and translation. So it's okay to take your time with it. So again, what we did is we took the slope of this blue line here that we started with. We saw that it was 2/5. We changed the sign, so it was positive, it's now negative. And we took the reciprocal, flip the numerator and denominator. And this tells us that 5 tells us vertical movement, and the 2 tells us horizontal movement. If you feel ready to go give Desmos a try, you can go ahead and pause the video. If you'd like to see a couple more examples, I'll be showing a couple more. So it says reflect over the y-axis. Here's the y-axis. Point A is, that's a little too thick. Point A is one space to the right, so now point A prime is going to be one space to the left. B was 1, 2, 3, 4 spaces to the left. Now it will be 1, 2, 3, 4 spaces to the right. Same thing with C, 1, 2, 1, 2. Connect your dots. And we get our new image. Here we've got translate triangle ABC. So the keyword there is translate. Using the vector +6, -1. So we're going to start, let's start at point A. We'll go +6, that means to the right 6. 1, 2, 3, 4, 5, 6. Y -1, down 1. This will be A prime. Again, repeat for B and C. 1, 2, 3, 4, 5, 6, down 1. B prime. Same thing for C. 1, 2, 3, 4, 5, 6, down 1. C prime. Just like we did before, connect your primes. And we do want to include drawing in a vector to show that translation movement. Last example is going to be a rotation on the coordinate plane. So rotate ABC 90 degrees counterclockwise. So remember that counterclockwise is in this direction, about the origin 0, 0. So here's the origin. We're going to be rotating counterclockwise, which is in this direction, in this direction. And what we're going to start with is, why don't we start with A? Since A is on an axis, we know that the 90 degree is just the next axis to the left. A was one space away, so it's not going to be one space on that new orange line. This is going to be A prime. Okay. So for B, since we're moving in the counterclockwise direction, since we are going to draw a line from the origin to point B like this, we're going to calculate its slope by creating a slope triangle. Let me erase that. So slope 1, 2, 3, 4. Here we have slope equals 2 over 4. So the perpendicular slope, the 90-degree angle slope, is going to be the opposite. So it's positive, so now it's negative. Reciprocal, flip it. Well, negative 4 divided by 2, that's just negative 2. So from our center of rotation, which was 0, 0, we're now going to count down 2, 1, 2, over 1. Down 2, over 1. And we're drawing a new line there. And we're going to basically plot that point. So we'll go down 4, 1, 2, 3, 4, over 2. And this new point is B prime. So you can see that we've created a 90-degree angle. Last example. Let's go orange. From our center of rotation, we'll draw up line to point C. The slope here, we need to figure it out. We'll do a little slope triangle. 1, 2, 3, 4, 1, 2. Look at that. The slope is also 4 halves here. So our 90-degree angle, our perpendicular slope, will be a reciprocal. So 2 over 4 and make it negative. So go down 2, 1, 2, over 4, 1, 2, 3, 4. This is C prime. So now let's connect our dots and see how did we do. Does this look rotated? And we can check to make sure that we've done this properly by connecting. It's a little hard to see with that thickness. By connecting the corresponding vertices. So A to A prime, yep, that's a 90-degree angle in the proper direction. B to B prime, yep, that's a 90-degree angle in the proper direction. And C to C prime, yep, that is a 90-degree angle in the counterclockwise direction. So this blue, dark blue triangle that we've created is the pre-image that has been rotated. All right, let me know what questions you've got.